Hello, we are Team 2813, the Gearheads. I'm Kyle.
And I'm Sierra.
And welcome to our third Java training video. On today's agenda, we have inheritance, strings, but again in more in depth, and printing to the console, again, but more in depth. So first, we have inheritance. So inheritance allows classes to borrow information and functionality from another class. For example, a vehicle might describe the number of wheels, and a motorized vehicle might also have a type of fuel, and finally a car and motorcycle would define how many wheels there are. Another way to think of it is inheritance models a class being another more specific version, or an is-a relationship. For example, a car is a motorized vehicle, and a motorized vehicle is a vehicle, but a car is not a motorcycle. And to actually model inheritance in Java, you use extends. So if we say that vehicle is a superclass, or the class that is a parent of motorized vehicle, then we say extends. So motorized vehicle subclasses vehicle and gains all the information contained in vehicle. And here we don't actually have any of this information because it would take up too much space. So there's this weird thing called polymorphism. So inheritance is a relationship, but you can also store stuff in a less specific class type. For example, here, if a car is a vehicle, we can store an instance of car in a variable that stores vehicles. And it is actually possible to do this conversion backwards using casts. So you have parentheses, the type you want to cast to, and then another parentheses. So this will only succeed if whatever the thing in the variable is can actually be successfully assigned. For example, if vehicle is a motorcycle, this cast will fail at runtime with a class cast exception. We'll talk about exceptions later. You can use instance of to actually check if the runtime type is compatible. For example, vehicle instance of car will return true if and only if vehicle can successfully be assigned to a variable of type car. So this cast is guaranteed to succeed. So there is a superclass of all classes, which is the object class. It has a couple of things. Equals, that takes in any other object and returns if it's equal. This is what you should use with any two objects with equality, not equals equals. Equals equals will check if they're the same exact instance, and equals is usually more accurate. Get class, this gets a class object that represents the class that this class is an instance of. What exactly this is out of scope of this training. And hash code, this is for returning a hash, which is used in some various methods, or some various objects such as hash map, hash set, etc. And there's also toString. This gets a string representation. This is what's used when you use println or print to print out an object. So, overloading. You can actually have multiple methods or constructors with the same name but different arguments. So, yeah. They can also have different return types. So, for example, Boolean is valuable. It takes string A and string B. This is good, and then this is also good, even though it also has string A. And this takes in a string and a string, so it has a different parameter list than this. But these two, or these three, all take in a string. It doesn't matter that this has a different name, and this has a different name, or that this one returns a different thing. They take the same parameters, so Java can't know which one you mean. And there's also overriding. So it is possible in a subclass to override the functionality of a method. So for example, in vehicle, we have a method to return the name. In car, we override that to make it return a different thing. So Java will always call the most specific implementation. So if you look at the actual class that the object is an instance of, and go up the class hierarchy of its parents, it will choose the first time that method exists. So for example, with car, which is an instance of car, it'll see, car has a name method, and we'll use this implementation instead of this. This at override here, this just tells Java, hey, I'm trying to override. And since I'm trying to override, yell at me if I'm not actually overriding anything. In this case, it'll print out vehicle and then car. So these have kind of similar names, but here's an overview of the differences between them. So overloading is defining multiple functions with the same name. Different overloads may have completely different functionality. An important note about overloading is that you should not be able to pass the same set of arguments to two different overloads and have it do two different things. If you can pass the same thing to two different overloads, then they must do the same thing. Otherwise, things will get confusing and not work properly, or could not work properly. Overriding is changing the functionality of a method. Only one override can be called for a method, which is the most specific one, and you can override an overload method, and only the method with the same signature will be overridden. Occasionally, you want to be able to define stuff that classes can use. So, for example, interfaces, defined with interface, it defines only functionalities. It defines a set of methods right here, which are all the methods that any implementing class must implement. And you can use this just like any other class type and call methods that exist in the interface. Abstract classes are similar to interfaces, except they can also have state. You can implement as many interfaces as you want, but you can only extend one class. In abstract class, you would need to extend. So it would be able to define some functionality as well as, or it'll be able to provide partial implementations with state. Interfaces don't really have state. They have static state, but not instant state. So for all of this is a pretty long section, but we do have a programming project for you to work on. So make a class hierarchy that has a representation of something that is fixable, a representation of something that can be fixed, and at least 3 different representations of things that are fixable. Additionally, at least one representation of a fixable thing must be of the type of the fixable thing that's represented. This is worded really weirdly, sorry. The representation of something that's fixable must have a method to fix it, returning true if the fix is successful. In a couple seconds, I'm going to swap to a slide which has a visible hierarchy that you can look at. So here's the hierarchy to look at. We have interface fixable, which door implements, and we also have an abstract class, which vehicle is also fixable, and we have both class car and class motorcycle, which both extend vehicle. For the class hierarchy solution, there are a lot of different things that you could have done for like things that can be fixed. In this example, we have a door can be fixed, and vehicles are a type of thing that can be fixed, and motorcycle and cars are both vehicles that are fixed because vehicle is fixable. In this implementation, a door is not fixed, and then if it isn't fixed, it's now fixed, and it has been fixed. Otherwise, it has been fixed since it was already fixed. For vehicle, the implementation just has each vehicle has a price, and then if the price is less than or equal to their repair budget, then their repair budget minus equals the price, so that basically paying for the thing to be fixed. And then, yeah. Then we turn true if we succeeded, and if we didn't have enough budget, then we turn false since we didn't have enough money to get it fixed.
Okay, now we're going to go more in depth into strings. So, let's talk about what strings actually are. So I know we were a little bit vague on it before, but basically it represents a sequence of characters, like we said earlier, and they're actually objects and not a primitive type like int or double, which means that you can't do the same thing that you do with primitive types as you do on strings. They're also immutable, which means that you can't change them. And one more thing is that the JVM, or the Java Virtual Machine, actually automatically initializes string literals. So a string literal is something like, I love Java, for example. And remember always to use double quotations when you're doing strings. And if you have multiple string literals, it'll also reference the same object. Okay, another thing is you can also add 2 strings together, which basically is like concatenating them, or that's what it's called. So you can do that with this little plus sign and then put 2 strings with each other, or you can also do the concatenate string method. And yeah, and this will actually result in a completely new string object because, like we said earlier, strings are immutable, which means that the original object cannot change. You can also get parts of a string, which is called a substring. And one thing to keep in mind is that strings are 0 indexed, which means that the first character in a string is actually going to be index 0 and not 1. And you can get substrings in 2 different ways. So you can basically do the substring method, and then you can put in your beginning index and your end index, or you can do substring method and just put beginning index. So if you do this one, then it will go from the beginning index to the character right before the ending index, which means that it's exclusive to the ending index. And then if you use this one, it will go from the beginning index to the end of the string. So for example, for the word taco cat, if you use substring 4, that means that it will go from index 4, which is C over here, to all the way to the end, which is T, so cat. And then if you use substring 2 to 6 with this whole string, then it's going to go from 2, which is this one, G, to 6, which is 2, 3, 4, 5, 6. So it'll actually exclude the space and just do gear. Okay, so you can also replace text in strings, which means that you can basically replace all the occurrences of a string within another string. So you can use .replace if you want to do that, or you can use .replace all, which we'll explain. So .replace, you can put in your target char sequence. Char sequence is basically just an interface that the string implements, and then you can put in your replacement, and that will replace all occurrences of that string, the target, within another. And then if you use .replace all, you can put in a regular expression and then put in the replacement regular expression, and that will replace basically the same thing, but it will replace all occurrences of that regular expression with with the replacement. And yeah, and if you only want to replace the first occurrence of something, you can also use .replace first, and that basically works the same way as .replace all, but instead it just replaces the first occurrence. If you want more information about regular expressions, just go to the link in the description, and you'll find one that's called regularexpressions.info. So a quick overview of all the things we talked about. So the concatenate or concat method just concatenates two strings. Substring, you can get a substring by doing substring and then putting in the starting index and then the ending index, or you can do it by just putting in the starting index. And the ending index will be exclusive for this type of substring method, and then for this it just goes from the starting to the end of the whole string. You can also use, like we just said, .replace or .replace all, and also .replace first for different replacing of the strings.
Okay, next up, more information on printing to the console. So, what is a print stream? Well, a print stream is just for outputting text to an output stream, which is some things. Output stream is a mechanism in Java for in and out, which is communication between your process, which is your code that's being run, and other stuff on the computer, or outside the computer, including the internet. So system.out is a print stream. Specifically, it outputs the output stream that goes to the console, or more specifically, standard out. It can be changed with system.setOut, which takes in the print stream. When you put in a custom print stream with setOut, when you're done using it, you should set it back to the original print stream. And also, don't worry about how it's actually implemented, because system.out is actually final. So, system.error is for errors, which outputs to standard error or std error, and can be configured with system.setError. And system.out is for normal output that's not errors and outputs to standard out or std out, and it can be configured with system.setOut. So, there are a lot of different overloads for printing. And print and println have almost the same overloads. All of them have overloads that take primitive types: boolean, char, double, float, int, long. And it prints the representation of the primitive type. For like a boolean, it'd be true or false. For char, it'd be the character. And for all the other ones, it would be just the value of the thing printed out. And then for strings, or char array or string, it will print the concepts of string. The char array is converted using the default char set. And then object, it uses object.toString to convert it into a string, and then it's printed just like a string. Technically, for this, it doesn't actually use object.toString. It uses string.valueOf, which takes in an object. The only difference between this and object.toString is that it checks if the object passed in is a null reference, and it is, it returns a string that has null, otherwise it uses object.toString. So if you're actually printing a non-null object, then object.toString will get called. And finally, the difference in overloads is that println has an overload that just takes no arguments, and all it does is append a new line to the output stream. Now, printf. So, printf takes in a string that is a format string, and then a list of arguments, which are objects or anything. So, this ... means that you can put a variable number of things. You can put 0 things there in just the format string, or you can put in any number of them, practically. And then basically what I'll do is we'll replace the next thing in args with the thing. So for example, if you put %d, then the next argument that hasn't been used will be assumed to be an integer, and it will be placed into where %d is in the string. If you've ever used C++, this is very similar to printf in C++. So some common ones are %d, which will place integer, %f will place float, %s, which is for string, and %n, which is for new line, which will use the correct new line for the platform. So one important thing to notice is that there's actually a large amount of detail for the stuff you can actually do with this. And this link here, which will put a link in the description as well to this documentation, has all the information that you'd actually want to learn about this, because we also do not have enough time to actually talk about this, because this documentation is very long. Specifically, the documentation that I've linked is 29 pages, 599 lines, has 8,037 words, and 48,740 characters just in the class description. So yeah, there's a lot. Now for your programming project, or the last one of the video. So for the project that you started earlier in the video, add a main method to it, and then try to fix at least one of every item. Additionally, add a method somewhere to the representation of something that can be fixed to get the name of the item. Finally, after attempting to fix each item, print out the name and if it was fixed. Pause the video if you want to work it out, and we will continue with the solution.
Okay, now let's take a look at the solution for this project. So remember, our interface, fixable, had main method fix and name, and since car, door, and motorcycle all implement fixable, they all will have a name and fix method. So for car, let's just explain this really quickly. But how this formatting works is, for this part at least, you have your condition in the front, so car.fix, and then it says, okay, if it's true, then do this. If it's false, then do that. And car.name is just car.name, and basically what will happen is it'll say the name of the car here, and then it'll say was, and then if it's true, it'll say fixed, or if it's not true, it'll say not fixed. So it puts car.name's result here, and it puts car.fix's result in here. Okay, great. And this one is just a new line. So yeah. Next one for the door, pretty much the same thing, but instead it's for a door. And for motorcycle, again, same thing, and it's for a motorcycle. So yeah. So for example, if you have a car called Lightning McQueen, and you have and it is fixed, so this returns true, then it's going to pick this one, and then the string you'll get is going to be Lightning McQueen was, and since this is nothing, it'll just go away, fixed, and then it goes to the new line. And if you have a door called, I don't know, my door, and the door is not fixed, so this returns false, then it's going to go to this one, and you'll get my door, and then was not fixed, or not, and then fixed, and then new line. So yeah,